6 phases. Okay, the first one is the project idea. The second one is the characterization of the project. The third one is the identification of data. Okay, this can be made through IoT or industrial Internet of Things or 5G or stuff like that. Then we're going to go and we're going to select the data. On number 4, we're going to clean it. We're going to transform it. After that, we're going to perform an analysis, then a visualization, and this is going to happen in an iterative way so that we can adjust steps 3 to 6. Remember always that the nature of a data science project is always iterative. Okay, it starts with some business understanding, then gets you to some data understanding, then this gets you to some data preparation. This gets you to a model, which gets you to an evaluation, which leads either to better understanding or to an implementation. Okay, so it is never a linear process. So don't expect that the first solution that you get is the best. This is never, or almost never, the case. So we start with our project idea. Okay, that can come from the IT department, from an external consultant, from a competitor, from a rollout, from corporate, from central departments, or to spend a certain set of budget. Okay, whoever has the idea is then the sponsor, and whoever's paying is going to be after the goal achievement. Keep in mind that not all projects are desired by those that need to implement them. Okay, some projects are just compulsory. The second step is the characterization, and here we ask the question why, and then we try to clarify what is the current state. Then we ask the question what for, and then we try to clarify the goals. Then we try to clarify the scope, okay, and we ask the question what, then clarify the phases, when, then the team, who is going to do it, then the method, how is it going to be done, then the success needs to be defined upfront. What are the bottlenecks? Something that you can do is a SWOT analysis. Then the cost, how much is it going to cost, and then the end product or the customer need. And this can be clarified through a CPOC analysis: supplier input, process, project, output, and customer. Okay, so the third aspect, the third phases of a project, it's given by the identification of the data, okay, and the data can come from different technologies like 5G or Internet of Things, which is called IoT, or industrial Internet of Things, IIoT, or it can come from geodata, okay, like cars driving around, or it can come from social media, Twitter or TikTok, I don't know, okay, WhatsApp. Important thing is that social media, important thing is that you know that whenever you're sharing information in the internet, whenever you're navigating the internet, there's always a third guy in the room, okay? So make sure you're careful with the data, with the information you're sharing, because as of today, with just one picture and basically just one picture, people can find you where you are actually now, okay? With just one single picture, just by triangulation and network analysis, okay? So be careful what you share in the internet and who you give your data to. So whenever you are dealing with a project of data science, the first thing you ask to the customer is a data test must always be asked for. So the customer is going to give you the first thing, one data set to try, a dummy data set. And we must know the processes behind the or the processes to be dealt with, okay? If, let's say, we are going to implement SAP in a factory, you not only need to know how to implement SAP, you also need to know the processes that later on will be subject to the SAP environment. Meaning that you need to go and look at it from a customer's perspective before you even start. Okay, so you go to the factory and you look at the processes and you try to understand the nature of the process, the nature of the data. Okay, important is that the data is trustworthy. So number 4, or 4.1 if you want, 4.1 is a selection. We have gathered a bunch of data. It is very important that the data are trustworthy. Here, remember one concept called blockchain. Okay, this makes the data trustworthy. If you would be with me in other class, supplier management, you would look at how to make a blockchain. So it is also very important that the data is made anonymous Okay, so nobody must know where the data is coming from. I don't know the name in English, Datenschutzgesetz, DSG, the law that protects customers must be taken into consideration. And before you even start, with the project, please make sure that the data management is defined in the contract. Okay. Please pay attention to the quality of the data, to the total number of data sets, the timely consistency. Okay, if there are data depending on time that need to be consistent, otherwise you cannot compare them, and of the variable consistency, that you have the same data set in the same variables, in the same measure. Okay, and this leads to or this needs to be done in order to make an appropriate normalization. Normalization. Okay, any questions about the selection of the data? Once we have selected the data, we continue. 4.2 with cleaning. Okay. Typically, when we get data, they are not clean. Okay. So we need to ask how many variables are there. Do we need to rename the variables? Do we need to transform the categorical variables? do we need to clean double data sets? Or do we need to eliminate or clean non-coherent, not dependent variables? There are some questions that can be or should be asked. So here in the selection, we are going to be asking about the quality of the data. Okay. In the cleaning, we are going to be also asking about the quality, but also asking about the format. Okay. Questions so far? For point 3, the transformation. Some gears, transforming energy. Well, here we'll look at do we need to eliminate null data or non-existing number, not a number, NaN. If there are empty positions, some so-called mistakes in the data, do we need to eliminate them? Do we need to eliminate outliers? For instance, if we have here a data set, a bunch of points here, and then for some reason we experience one data here, does this data point, this red data point, need to be there, or is just a mistake in the measurement? Do we eliminate it? Okay. Do we need to format variables to be able to, in order to compare them? We made an example in the beginning of the semester of this, how to format variables to bring them between 0 and 1, okay, to get a normal distribution. Or another important method, it's called the principal component analysis, so that you know, okay, And or do we need to create synthetic variables? Okay, this would be the creation of synthetic variables, variables that do not exist. Yeah, so this would be basically it. Any questions about the transformation? So we play with the data without losing, I'm going to write it. We play here, we play with the data, we transform the data. Without losing information. Okay. Because if we transform the data, it's easier or more effective its computation. Okay, any questions so far? Number 4. Good. Well, then we continue to number 5. The analysis. Once we have cleaned the data and represent and transform the data and so on and so forth, we need to make sure we make sense of the data. Okay, so here we bring an interpretation. A sort of intelligence to the data. And like, for instance, we could say that 90% of women like men with a six-pack. Good. But we could also say that 90% of men with a six-pack do not like women. Okay. So we have done some analysis, and at some point we get to some interpretation of the data. Okay. And we put it in a statement, a business statement that could be like this. This is valuable for the customer. Okay. The fact of the matter is that when we perform such a business analytics project, 20% of the whole time we spend with the data analysis, okay, with this step number 4, number 5, and 80 or 70% of the energy we spend into data transformation, cleaning, and selection. So if you want to think about a data analytics project and think that this is a flashy thing that is pretty, and think about it again, okay? Something attractive and stuff like that. Here, what you're dealing with is with a lot of numbers and data, and at the end of the day, you're dealing with a computer, okay? It is not very sexy, although necessary. Okay. So when we do machine learning, there are three types of analysis. Depending on their characteristics and their implementation. Okay. There are supervised analysis by experts. Okay, here we know how the solution looks like. We don't know the solution, but we know how it looks like, and this is done in classification, modeling, and predictive ML, predictive machine learning. When we want to predict certain future behavior. Then we look at some unsupervised machine learning analysis models. Here we do not know how the solution looks like. We do not know it. We do use this for clustering and dimensional reduction. Okay. And the last is the semi-supervised. Okay. This is a mixture of both above. And here, so we know a little bit. This is used on deep learning, for instance, projects, face recognition, visual recognition, stuff like that. Okay. So, any questions? Questions? Okay, so then the last point is the visualization. Once we have performed our analysis, we need to visualize, okay? We need to get some visuals. And we have seen some examples of this before. Here we use heat map to represent correlations. Or we use 2D representations, the KPI. So the curve of the virus is spreading, I don't know. The 2D representation, this is very intuitive, I guess. It gets trickier when we get it into 3D scatter plots. If we have a KPI 1, 2, and 3, this is time. Here we can have also a box plot with the median and stuff. Okay, so there are a bunch of different ways to represent information, and this is important for the management. Okay, to represent the results properly. We have seen this 2070. This is about our, let's say, last 3% of the capacity. And number 1, 2, and 3 here, this is about 2% of the capacity, and this is about 5% of the capacity. So that all in all, you have a 2%, 5%, let's say 3%, 7, 10, I don't know, 10%, and then we have here 10%, and then here 70%, something like that. Okay, this is roughly the numbers that so that you get an idea on how much energy you need to be taking into a project. Okay, any questions so far? Okay, well, let me stop recording the lecture.